Okay, this is part 2 of using Excel to work with time value of money problems, right? So the next thing we'll look at is moving away from the basics of calculating either present value or future value, and whether it's an annuity or not, and how we could solve for the other inputs, such as solving for the number of years or solving for the rate that we need, right? So let's look at a couple examples. Again, we already know the answers to these, so we'll just see how it works out inside Excel, right? So here's an example where we invested $1,000 today. It's going to be growing 10%, and in the future it's worth $13.31. So we want to know how many years is that going to take to grow from 1,000 to 1331 at 10%. We already know the answer is 3, but let's see how we do that in Excel. All right, so there's just one thing we have to be careful about. When you have both PV and FV in your formula, they have to be opposite signs of each other. Right, so let's see how we implement that. So we'll use F sub X. And this time, again, in our financial category, we're looking for number of periods, which is NPER. So there it is. It's going to look very familiar here. So the rate is the 10%. The PV, we'll put it as a minus the 1,000. And the future value is where we have the 1331. Okay, so notice what we did here. We've got the rate. Notice the PV and FV are opposite signs. Since we enter them both as positive in the spreadsheet itself, they have to be opposite signs in the formula here. So typically we make the PV the negative and keep the FV as a positive. Notice we're getting the answer of 3. Right? Now let's say that it's the percentage. So we're trying to see what rate of return would we have to get in order to grow our money from $1,000 today to be worth $13.31 3 years from now, right? So again, we'll use F sub X. This time we are looking for the function rate. Scroll down here till we get to rate. There it is. And the number of periods is 3. Present value with a minus sign is 1,000. The FV is the cell with 1331. And there we see we're getting the answer of 10%. All right. Now, a version of this is working with the rule of 72. Okay. The rule of 72 is an approximation of doubling our money and either solving for how many years would that take if we know what rate of return we're getting, or if we know the number of years, what sort of rate of return would we have to have? So look at it both ways, right? So first we'll solve this using Excel. So here's a situation where money is doubled. We've gone from 1,000 to 2,000, and we're earning 8%. We want to know how long would that take to double our money if we're earning 8%. So we're solving for the number of periods. So use F sub X, right? And we'll scroll down for number of periods. There it is. Right. The rate is 8%. The PV with a minus on it. Don't forget, again, whenever you have both PV and FV in your formula, they have to be opposite signs of each other. Okay. We solve, we get a little over 9 years. Here's where the rule of 72 comes in. The rule of 72 says you can approximate one of these numbers if you have the other by taking the number 72 and dividing by, in this case, the 8% is what we knew. So we divide 72 by 8, we get 9 as an approximation. And notice how remarkably close that is. Right? Let's do the same thing, this time solving for the rate, assuming we know the number of periods. We'll just change the numbers a little bit here, just so we mix it up. So come down here, we're solving for rate. So click on F sub X. We're going to solve for rate. Number of periods is 12. The present value, the minus sign, is where we've got the 1,000. The FV is where we've got the 2,000. Okay. We hit OK. And notice here, again, if we just increase the decimal, again, notice it's a very close approximation if we use the rule of 72. The rule of 72 would say take 72, divide by 12 years. That's roughly 6%. Notice Excel is giving us a much more precise answer, 5.95%. All right, so there's how to use a couple of the other functions and the idea of the rule of 72. The last couple of things we'll look at are setting up amortization tables. Okay. So amortization table is when we have a loan and we want to see we're paying off the loan periodically. And when we make those payments, the payment includes both paying off part of the loan balance itself, what we call the principal, and part is going towards interest. So in this scenario, similar to what our slides say, we're borrowing $300,000. The rate is 12%. We pay this over 4 years. We're just making one payment per year at the end of the year. So the first thing we have to solve for, a new function here, is the payment function, right? So we're going to use f sub x, and we're going to look for the payment function. So there's PMT, not PPMT, just PMT. Okay. So notice what it says. This calculates the payment for a loan based on constant payments and a constant interest rate. That's exactly what we've got, right? So the rate, 12%, number of periods is 4, and the PV with a minus sign in front of it is 300,000. Okay. So we get 98,770. The first thing to note, if we were to take 98,000, round it off to 100,000, multiply that by 4, we're making almost $400,000 in payments. The loan was only 300,000. The difference is how much we're paying in interest over the life of the loan, right? So let's set up what is known as an amortization schedule or an amortization table. So notice how I set this up. We've got our column headings. We're going to pay it off over 4 periods. I start with a row 0. We can see why. We got these various columns. We'll talk about them as we go through this. So I have a row 0 here, and we'll see why. So the balance at the end of 0 period, which is the beginning of year 1, right, is going to be equal to how much we borrowed. We call that the principal amount. Okay. So then our balance at the beginning of year 1, we use a formula now. Notice here, this is a formula. I didn't type in 300,000. I referenced cell B1, right? So now what I'm going to do, now I'm going to start row 1, year 1. I'm going to say that's equal to the balance at the end of the period, right? So that's going to be the case. So the balance at the beginning of each period will be equal to the balance at the end of the prior period. So what I want to do here is I'm going to create 1 row worth of formulas. Once I think they're correct, then I can just copy them down. So it doesn't matter if this were 4 rows, or as we'll see in the next sheet, 360 rows. We only have to get 1 row correct, then we just get to copy the rest of it down. All right, so let's see how this works. So the payment is the same amount each period. It's this 98,770. So I'm going to hit equals 98,770. I'm actually going to do this wrong first, just so you can see what goes on here. Right. So I enter 98,770. Now what I want to do is, again, as I start, once I have this row complete, I would highlight it, do edit copy, or I'll do Control C to copy it, and then I would copy it down. So Control V or edit paste. Okay. Notice what happened here. Okay. Particularly with the payment. If you notice what happened with the payment here, that should be 98,770 every period, but it's not. Okay. So we've got a problem. Okay. So the way we solve this, if we want that to be 98,770 every period, so let me just get rid of stuff here that I've done. Okay. 300,000 is good. So what I need to do is when I say equals 98,770, and then I want to be able to copy that down so it's always 98,770. what I have to do is use the F4 button, or you can type these in. You would put dollar signs in front of both the column reference, the letter, and the row reference, the number. So equals $B, $4. So let me just do that. And now if I do a Control C and a Control V, notice it copies down perfectly. The next cell down is still B4. Or it copied down again, it's still B4. So that is known as absolute referencing. I'm sure you learned that. To me, it's one of the most fundamental techniques in Excel, is to get familiar with using absolute references. If we don't use it, we call it a relative reference. Right, so let me just get rid of that. All right. So again, I've got my reference here equals $B, $4. The way we calculate interest is going to be equal to your interest rate. But again, that interest rate is always referencing cell B2. So once again, I need to hit the F4 button. So when I copy this down, it's always looking in the same cell for the interest rate. And I multiply that interest rate by whatever my beginning balance is for that period. Right? That I don't need to make absolute, because that beginning balance is going to keep changing each year. It's going to keep getting lower. Okay. And the last thing I need is the principal, how much of the loan have I paid off? So we made a total payment of $98,000. 36 of that thousand that went to interest. The rest of it is going towards reducing the loan. So the way I calculate this is simply the payment minus the interest. Okay. So 62,000 is going towards the loan. So then the way I calculate my balance at the end of the period is going to be equal to what was my balance at the beginning, 300,000, minus how much of that I've paid off, the 62,770. So once I've got that row correct, I'm going to highlight it, press Control C to copy it, drop my cursor down one row, then I'm going to use my Shift key and use my down arrow to highlight, years 2, 3, and 4. Now just hit Enter. And that copies everything down. And if you've done this right, at the very end, your balance would be 0. So that shows that we've amortized the loan correctly. So again, what we mean by amortize is to take a loan, show what the periodic payments are, in this case, $98,770 per year, then set up a table showing all those payments that we make. So at the end, after we make our final payment, our balance is down to 0. So we've succeeded. All right, so there's the basics of a loan amortization. Now let's look at one, same concept. We're just going to add a twist to make it monthly, which is how many loans, mortgages, car loans, we typically make our payments monthly. Right? So here's our final sheet next to final sheet to work with. The last one with amortization schedules. Right? So in this scenario, let's say we're taking out a mortgage of $100,000 to buy a house. It's a 30-year loan with monthly payments, and our interest rate expressed annually is 6%. So the first we have to do is calculate the monthly payment. So we have to be careful here. When you're doing monthly payments, you have to convert everything to months. So that means the length of the loan, we have to convert from 30 years to how many months that is. So it'd be 30 times 12. The interest rate, since it's expressed annually, we have to put that on a monthly basis, which means we divide it by 12. Okay. You can do that in separate cells, or you can do it inside the formula. I tend to do it inside the formula, right? Either way is fine. Okay. So let's see how I do this. So at F sub X, once again, we're solving for payment. We just did that on the previous schedule. So here's payment. So for the rate, it's cell B3, but I'm going to hit /12. That'll convert that to a monthly rate. So take an annual rate, divide by 12, puts it on a monthly basis. For the number of periods, it's cell B2, but times 12. Notice 360. It's how many monthly payments there are in 30 years. And the present value, how much did we borrow? How much is the mortgage? put a minus sign in front of that, we get 100,000. That's equal to 100,000. And we hit OK. And there's our monthly payment, $599.55. Okay. So what I pre-filled in, because sometimes it's just confusing to go over that, but I put in all the rows going down to 360 here. So I think, wow, this is going to take forever. Again, just like the previous one, all we have to do is fill in what the first period looks like and then copy it all down. All right. So if you recall, how do we do this? We start with row 0. And we're going to set equal, the balancing end of the period equal to how much we borrowed, 100,000. Okay. Then we'll drop down to row 1. We'll say the balance at the beginning of a period is equal to the balance at the end of the prior period. Okay. The payment, that equals that monthly payment I calculated. But again, we have to make it an absolute reference. So we hit the F4 button. Again, if you're working with a Mac, it's a little bit different. Just type in the dollar signs in front of both the column and the row reference. So your formula would say equals $B, $4. Right? So we've got that. Recall the way we do interest is going to be equal to your interest rate times your beginning balance. But here's the thing to be careful about. Again, the interest rate here is the monthly interest rate. Right? So to do this, we're going to say equals, and we put in parentheses, the annual rate. But remember, like on the previous sheet, we want to lock that cell reference in so that when we copy it down, it's always looking at cell B3. So I've got to put dollar signs in front of it using the F4 button. I'll divide that by 12. So that's going to give me my monthly interest rate, right? And then I'll multiply that by my balance at the beginning of the period. So 500. Then the principal repayment is the difference between those two numbers. Here's my total payment. And $500 of that went towards the loan, right? And then my balance at the end of the period is where was it at the start minus how much of it did I repay, the principal repayment. So there's my first row. Hopefully everything's done correctly. It's got a built-in check, if you recall. Do Control-C to copy that. So now that's highlighted, right? And a fun fact, if you look at this, you see these sort of, looks like moving green line around the box that you've copied. Some people refer to that as marching ants. That's sort of what it looks like. So little trivia there, right? So Control-C, I'll drop my cursor down one to go into row 2. Now I'll hit my Shift key, and I'm going to start hitting page down. So just go more quickly. So go all the way to row 360. I'll hit enter. Fills everything in for me. And fingers crossed when we get to the very end here, row 360, look there. That very last payment brought us down to a balance of 0. All right. So there's what's known as a mortgage amortization schedule. All right. The last thing we'll look at here in terms of using time value of money is with bonds. Okay. So we're going to look at 3 scenarios. So we're looking at, so typically corporate bonds, the face value is $1,000. The face value is how much the company has to pay back at maturity. Typically, that's $1,000 per bond. The coupon rate is the rate that's set at the beginning. That's what's used to determine how much your interest payments are. We will assume, like many corporate bonds, that they pay interest semi-annually. So we think about this. This is paying 14% times $1,000. So the annual interest paid is 1,000 times 14%, or $140 per year. We just split that over 2 payments per year. So we divide that by 2 to get 70. Right? So let's just calculate that here. Skip down to here. This has 6 years to maturity. And we're going to assume initially that the going rate of interest, so this could have been issued 14 years ago. It's a 20-year bond, perhaps. It was issued 14 years ago. There's still 6 years to go. So interest rates have changed. So now we're saying in this first scenario, the interest rates have stayed the same. Right? So let's calculate the interest payment. Again, the way we calculate that, that's going to be equal to the face value. Let's do it this way. Use parentheses, the face value times the interest rate, and then divide by 2. Right? So now we'll just calculate the present value of those interest payments. Essentially what we're doing, if we come over here, should have set this up originally, but here's today. So we're buying this bond today for some price, okay? Then every 6 months. So here's payment 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And we are getting $70. Each of those, okay? We want to know what's the present value of that. What is that worth today? That's an annuity, right? An annuity is a series of payments, equal payments over so long. So it's a present value of annuity where the payments occur at the end of the period. Okay. So we already know how to do that, right? Let's work on that. So this is a present value. So with f sub x, find our PV function. So the key thing to use here, right? When you're using the formula, use the market rate of interest, not the coupon rate, use the market rate. So this first scenario, they happen to be the same, right? We just have to be careful here. So that's the market rate. But again, since everything is semi-annually, we divide it by 2. Okay. Same thing with the number of periods. We take the number of years. Oops, I was thinking times 2, right? To fix that little table I set up, I was thinking 14. Oops. Let me just do that now. So this should have only been, oops. Payment 12. I was thinking 7 years, 14 payments, 6 years, so it's 12 payments. It's payment 12. Not that does anything here. So let's go back and do this. So this is f sub x. I'm calculating the present value. And fill in the rate. Again, use market rate of interest, but we divide it by 2. The number of periods is 6 times 2. Right? The payment with a minus sign, as always, is that $70. Right? And we hit OK. Right? So that's part of it, right? So this bond is making 2 types of payments. One, every 6 months for 6 years, we'll be getting $70 of interest. The other thing that's going to happen is at the end of 6 years, we're going to be getting our $1,000 back. So that's a lump sum. So we need to calculate what is the present value of a lump sum that we're receiving 6 years from now, but we have to put that on a periodic or semi-annual basis as well, right? So let's come down here in f sub x, same thing. Let me switch this to recent, so it's just everything's right at the top. So there's present value. The rate is the market rate of interest divided by 2. Number of periods is the number of years times 2. We're not dealing with the payment now. We already did that. We're dealing with a lump sum. So we come down to future value. We'll put a minus sign in front of it and click on the 1,000. Right. And so the total present value is equal to those two numbers added together. So we get exactly 1,000. Right. So that's what we'd expect. So when the coupon rate is exactly equal to the market rate of interest, we will get present value of $1,000. That's what the bond would sell for under that scenario. Right. Now let's look at two other scenarios. Right. Here's the situation, this premium, where here's a bond paying 14%, and the market rate of interest is only 12%. So this bond sounds pretty good, right? It's pretty attractive. And when something is attractive, it might be able to demand a higher price. So if we did everything correctly, we should be able to just simply highlight these numbers and copy them. Right? And that's what this bond would be selling for right now. Okay, so since it's more than the face value, we say it's selling at a premium. The reason it's selling for a premium is because the bond's coupon rate is greater than the going rate of interest. And finally, let's just highlight that group of cells, copy that over to here. What we have in this last column is the bond selling at a discount, less than 1,000. The reason it's selling for less than 1,000, our bond is only paying 14%. The going rate of interest for everything else, similar type securities, similar risk profile, is paying a high rate of interest. So the only way anybody's going to buy our bond is if they can get a good price on it. They get it at a discount. So there we go. So this would only be selling for $924. Okay. So there is the end of looking at how to use Excel and working with time value of money problems. Okay. So we'll stop sharing and I'll stop recording.